Continuing lesson IN5, rate of change in slope. We're going to look at some problems on this worksheet that I've given you. Again, this is not in your books, just something extra that we have from the book company to get some more practice on this. So on the first problem here, apparently the book has changed this a little bit, which is a good thing. One thing is we have our triangle, which is not what we want it to be underneath here. We've talked about not putting it there. The other problem is we have a point that's kind of in between that they're wanting us to use, so that's not really going to work out very well. So again, to find the slope, to find the rate of change, what we need to do is to find 2 points on the graph that the line goes exactly through. So one point that this line goes through for sure is the point 520. Another point that the line goes through right on the edge of the graph here is actually the point 1040. You might notice 0, 0 is a point that this line goes through. Just to make things a little interesting, not all points are going to go through 0, 0 like we were mainly talking about in the first part of the lesson the other day. So let's just go with these 2 points, 520 and 1040. So for slope, the book talks about slope being a rise over run. We talked about slope being a change in y over a change in x is another way of thinking about that. So if we think about our change in our y values, remember these points x and then y, and if you want to label that, even though you guys know what that is, sometimes we get backwards because we're doing the points are x and then y, but when we do the slope we look at the y and then the x, so it's easy to get those mixed up. So change in y, I'm thinking about that my y went from 20 to 40. So to find the change, basically we're subtracting those. Okay, so if you wanted to actually have some work to show what you did, you could say let's take 40 minus 20, and that tells me how much we changed by. So the change in y would be 20. And the change in x, if we look our x values, we went from 5 to 10. Okay, so change in y was this part, we went up 20. Change in x is how far we're going over. So we went over from 5 to 10. So that would be a difference of 5. And again, we can get that by subtracting our x values. 10 minus 5 is 5. So if we're filling in the blanks here, we could say our rise over run, our rise is 20, the run is 5, and then if we take 20 divided by 5, is 4. So the slope of this line is 4. I'm really not sure what they're talking about because they don't have the x or the y labeled on the axes here. What's is this miles per hour, or I really don't know. So we'll just say the slope is 4 and call it good. And again, when you look at these points we talked about the other day, also just a refresher, the slope, if it's positive, is going to be going this direction somewhat. Negative is going to be going this direction somewhat. So that's another thing to keep in mind when you get your answer, thinking about if your sign is correct or not. If we look at number 2, they want us to find the slope of the line, and they talk about using this formula. Just remember this formula is basically saying subtract your y values in the numerator, subtract your x values in the denominator. So subtracting the y values, that's the change in y. Subtracting the x values, that's the change in x. So nothing really different, although it does mention the idea of actually subtracting these, which we'll talk about a little bit more here, because we for sure have this line that does not go through the point 0, 0. So we have to be kind of thinking about subtracting in order to figure out what these are. Also, these points, if you'll notice, the points they gave us are kind of in between points. So, we can't just say I'm going up this many squares and over this many squares. They're in between, so that doesn't really work out quite as nice either. Okay, so the change in y, what I like to do is start with the lower point. Actually, the further to the left point, I should say. Further to the left point, which is -1, -5, and then going up to the further to the right point, which is 2, 1. What that allows me to do is go ahead and look at my change in y first and then my change in x. So change in y, if we look at our y values, our y value is going from -5 up to 1. So we're wanting to think about how that worked if we went from -5 to 1. So finding that change in y, like the book shows us there, we can one way of looking at it is we can subtract. So we could say, well, let's take 1 minus -5. And if we do 1 minus -5, when we're subtracting like that, we'll need to add the opposite. It becomes 1 plus 5, or 1 plus a positive 5, which is 6. Okay? Same idea when we look at our x's. Our x's, we went from -1 to 2. So let's subtract our x's. Now, one thing we have to watch for when we do it this way, we have to find the change in x the same way we found the change in y. So in other words, the change in y, we started at 1, which was from this point. We have to also start from that point when we look at our change in x. So if we were working this out by hand, subtracting, we would have to say 2 minus -1. If you don't do it in the right order, basically you're going to get the wrong sign on your slope. So that would be an easy thing we can check for. Add the opposite basically makes that 2 plus 1, which is 3, and then 6 divided by 3 is 2. So the slope of this line is 2 if we've done this correctly. And again, think back to what we talked about a minute ago with the directions. The direction that this line's going, does this look like a positive slope? Yes, hopefully. Okay. And so since this is the right direction, then we're probably okay. In other words, if you did it in the wrong order, the change in x, if you did it in the opposite order of your change in y, you would get -2, and then you'd have to say, well, negative slope would be going the other direction. That doesn't make sense. I must have done one of those in the wrong order, subtracted in the wrong order. Okay? And again, if you graph these differently, if you use graph paper and graph them and you got them on exact points and you can count squares and they're not very far apart from each other, that's fine also. Then you could say I went up 6 and over 3, or I went up 2 and over 1, you could maybe even see, and figure out that slope would be 2 there as well. Number 3, you will notice a difference. Difference being is they did not have a graph drawn for us here. Okay, so we have a couple of options. One option is we can just kind of think about what's going on like we did on the last problem. We can work it out by hand. The other option would be to actually graph the points. Even graphing the points, if you want to, you could even just sketch out a graph of approximately what it looks like. These numbers are a little bit bigger, and so I may not want to go by ones going to 24. If you want to go by 4s or 6s or something like that, that's fine. Or like I said, if you want to, we can kind of just sketch out what's happening here. 0, 10, 0 for the x, 10 for the y would be something like that. 24, 6. Whoops. 24, 6 over 24 up 6 would maybe be up here. So just by sketching this even, this isn't an exact drawing, but by sketching it out, we might have an idea that this is a negative slope. So change in y over change in x, I like to start with the point further to the left. That helps me to get my change in y first, and then my change in x. So change in y, we're going from 0, 10 to 24, 6. And again, we want to look at our y values, which are the 10 and the 6. So I went from 10 to 6. So we're actually going down. So my change in y actually is going to be negative, if we want to think of negative as going down. So rather than just saying, well, let's take 10 minus 6. 10 minus 6 is 4. That would make our change in y be positive. If we do it in the other order, 6 minus 10, and then we can add the opposite, 6 plus negative 10 is negative 4. So that shows our change in y as being a negative. That would be with starting with this y value on the point further to the right. Okay, and we can always do it that way if you want. And then we look at our change in x. So our x values, we're going from 0 to 24. And so we're going over 24. So that one, again, since we started with the 6 for the y, if we were working this by hand, we would just have to start with the 24 for the x. So 24 minus 0, which is 24. And then we can just reduce these if you want. Reduce both of them by 4. And so our slope would be negative 1/6. So negative like we were expecting. And again, with practice, we'll get an idea. Negative 1/6. It's a negative slope. 1/6 is not a real big number, though, so it's not a very steep slope at all. Okay? It's not like it's almost going straight up and down by any means. Now, if you look at this problem, what we just worked out, and you might say, well, what if I didn't sketch it out? And how would I know what order to go in? And the answer is, actually, it doesn't matter. As long as you're consistent, it doesn't matter what order you go in. So with the y's, in this case, we did 6 minus 10. If you did it the other way, would be 10 minus 6. And we can actually do this and get the same slope. And you might say, well, how is that? Well, if we did 10 minus 6, we started over here. Then when we do our change in the x, we also have to start over here. And so then we would do 0 minus 24. And then again, in both cases there, if you want to add the opposite, you can. You don't have to in the numerator. Obviously, 10 minus 6 is 4, but autopilot might have you add the opposite anyway. 10 plus negative 6 is 4. 0 plus negative 24 is negative 24. And then if you reduce, you get 1 over negative 6, which is the same as negative 1/6. So if you don't even want to sketch it out, if you want to work it out by hand, you can. You just have to make sure whatever y value you start with when you subtract in the numerator, you have to start with the x value from that same point when you subtract your x's. Okay, and like I said, if you don't like that as well, you can just sketch something out and then just use your sketch to kind of help you work it out. Technically, we could sketch it out, go by ones and count squares, how many squares we're going. Doesn't really work though when our points have maybe hundreds or thousands or millions in it. So it might be good to have a backup plan in case we can't count squares. So if we look at number 4, similar situation. Again, if you want to actually draw those exact points, you can. If not, we can kind of just sketch it out. Either way is okay. I'm just going to sketch it out here. 0, 6 is going to put me on the y-axis, and then 20, 14. 14's higher than 6. Bigger than 6, so something like that. And again, just by graphing this sketch out, I have an idea of what kind of slope I'm going to have here. So as we go left to right, this is going up, which means we have a positive slope. So I'm expecting my answer to be positive, something to think about. Okay, so finding the slope here, we're going to find change in y over change in x. So if we think about our y values here are the 6 and the 14. If you want to think of starting on the one on the left is usually what I like to do. Then we can say we went from 6 to 14, we went up, so that's a positive number. Okay, and the difference there is 8. If you want to have some work to show for it, in case you accidentally subtract wrong, or so we can actually have some work rather than just an answer, would be probably a good idea. We could write down this 14 minus 6, which is then 8. Our x values are 0 and 20. We're going from 0 to 20. So we're going over to the right, which is positive 20. Again, we could subtract those. 20 minus 0 is 20. Again, notice I went in the same order. I started with the 14 for the y. I started with the 20 for the x. Same order, then I'm okay. So I've got 8/20ths, and then it's just a matter of potentially reducing if I can. Always want to reduce fractions if possible. So we can actually reduce these by 4 if we see that, which would be 2/5, or you can reduce by 2 and then reduce by 2 again. Okay, 2/5 is a positive slope. We were expecting a positive slope, so that's good news always when that matches up. Number 5, graph shows the number of centimeters a particular plant grows over time. What is the slope of the line, and what does the slope mean? So first thing we know is we're going to have to look at the graph and find 2 points that the line goes through. So one point that the line goes through is 2, 3. And another point right on the edge here actually would be 4, 6. If you'll notice on the x-axis they're actually going by halves, right? So right after 3 would be 3.5. And then 4. So always watch the scale, watch what they're going by. Another point here would be 0, 0, which you can use if you'd like. Just remember they won't always go through 0, 0, but we'll talk about that in a minute after we work it out this way. So finding the slope, again, we're going to look at what our change in y over change in x is. So before we actually work this out, we might want to think about the fact this is going up as we go from left to right is going to be a positive slope. Change in y, our y values are 3 and 6. And so if we start on this point on the left side, we would actually be going up 3. The y-axis, they are actually going by ones, so we could actually count the squares there. Usually not the case, doesn't seem like lately, but so 6 minus 3, we're going up 3. And then the change in x. So our x values are 4 and 2. So we could subtract those, and that would actually be 2. Again, it's going over 4 squares, but they're going by halves, so watch out for that. So 4 minus 2 is 2. Okay, this time we are talking about how much a plant is growing over time. So it probably would make sense for us in this case to actually find a unit rate. Just divide that out. So if we divide that out is 1.5 or 1.5. And if we look at our units, this is slope is change in y over change in x. So if we look, our y's deal with the height in centimeters, the x deals with the time in weeks. So we basically divided centimeters by weeks, means we're going to get centimeters per week. Okay, and this is positive, so it would make sense we could actually put a plus sign in front of here. Normally we don't necessarily do that, but that helps us to see this plant is actually, the height is increasing by 1.5 centimeters per week, which is a good thing. Okay, now one other thing to mention to you guys, since this went through 0, 0, we won't always get this case, but if you do, remember if it goes through 0, 0 and if it's a straight line, it's proportional. If it's proportional, we can look for our unit rate point. In other words, at 1 week, how tall is it? And it's in between point here, no guarantees, but it's looking like after 1 week it's 1.5. So that actually is our rate of change or slope since it's proportional. Okay, so that would be kind of a shortcut way since it goes through 0, 0 and is a straight line. Not going to be able to do that on every problem though. And then to answer their question, we already talked about it a little bit. On part B, it asks what does the slope mean, and that would be that the height is increasing 1.5 centimeters every week. Number 6, a machinist measures the thickness of a grinding pad every week. The graph shows how many millimeters the grinding pad has worn down. What is the slope of the line and what does the slope mean? Okay, so notice you might expect, at least I was expecting looking at this graph, is that this grinding pad thickness is being worn down. I was expecting to see a negative slope, but actually they're just phrasing it different. They're saying how much thickness is lost at this point. Okay, not how thick is the pad still, how much thickness have we lost. So that's why actually this is a positive slope, you might notice. So to find the slope, we need 2 points that the line goes through for sure. And here's one. Halfway between 10 and 20 would be 15. So 415 is 1 point that it goes through. Another point they've got kind of marked for us is 830. Once again, you could have used 0, 0 as a point, but as long as we get 2 points that it goes through, then we're in good shape. Like I said, this is a positive slope, so I'm expecting a positive answer when I find this. Change in y over change in x. If you guys want to, even as you do these problems, if you want to use colored pencils or something and mark what your y's and your x's are so you don't get mixed up, that's fine. Whatever it takes for us to come up with the right answer. So for the change in y, we could take 30 minus 15, which would be 15. By how we worked that out, we actually started over here with the 30. So if we do the change in x, we're going to want to go in the same order. In other words, we need to start over here with the 8 and take 8 minus 4, which is 4. Okay, so 15 fourths. Actually, if we look at our units, that's telling me we're losing 15 millimeters every 4 weeks. Unit rate might be a nice thing to know as well. So this is millimeters per weeks. If we divide that out, that'll tell me how many millimeters per week we're losing. So we could just change that to a mixed number, which is 3 3/4. The decimal's not bad in this case. So if you want to say 3.75, okay. So 3.75 millimeters per week is how much thickness is being lost. Okay, again, it's kind of backwards a little bit how they did this problem, but that's okay. And then part B, it says what does the slope mean? And again, we can say that the thickness of the grinding pad decreases by 3.75 millimeters each week, or the thickness lost is 3.75 millimeters per week. Number 7, you use a garden hose to fill a circular wading pool that is 39.6 centimeters deep. You measure the depth of the water every 2 minutes. The table shows the data. What is the slope of the line? And what does the slope mean? And how many minutes will it take to fill the pool? So they're actually having us do something with our slope in this case, and just instead of just saying what it is. With this, we actually have 6 points that are given to us. Okay? That's just more information than what we need. We know that we only need 2 points. So you can actually pick whatever 2 points that you'd like. As we look at these to look at what points we're going to be picking, usually if a table is given to you, on the left will be the X and on the right will be the Y. Also, usually time is X if it's involved, and the other variable is the Y. In this case, think about if we're finding the slope, it's either going to be minutes per centimeter or centimeters per minute. One might sound more correct to you. In this case, centimeters per minute might sound more appropriate. So, change in Y over change in X. If you want to actually pick these first 2 points, 0, 0 is actually kind of a nice point to use if you have it there. Change in Y, so our Y's are going from 0 to 4.4, so change in Y is 4.4. Minutes went from 0 to 2, so that change is 2. And so 4.4 divided by 2 would be 2.2. So our slope is 2.2. Since we already have decimals here, you can just leave it with the decimals is okay. So the slope is 2.2. And then the question on part B, what does the slope mean? So since our slope is positive, we could say that the depth of the water is what we're talking about. It increases by 2.2 centimeters per minute. Okay, and then part C, how many minutes will it take to fill the pool? So different ways we could do this. We could do this an easier way or a harder way. Easier way would be to say 39.6 centimeters is the depth of the pool, and we're going up 2.2 centimeters every minute. If we divide, that'll tell us how many minutes it'll take for us to fill up the pool, and so that would be 18 minutes. The more difficult way to do this would be to actually continue the table if you want, and keep increasing. On the table, it's increasing every 2 minutes, a certain amount, 4.4. Or you could just keep increasing 1 minute by 2.2 until you get to 39.6. The bad thing about doing it that way is if it doesn't take an even number of minutes, let's say it takes 18.375 minutes, I'm not going to be able to find that on my table. By dividing it, even if it doesn't come out evenly, I'm still going to find that exact answer. Number 8, graph shows the number of kilometers Gina swims. What is the slope of the line and what does it mean? So again, we need to find 2 points here. Realistically, 0, 0 is a nice looking point if you want to pick that as one of your points. And then really right here actually is a point. We'll have to figure out that that's a 3, but that would be the 0.13. Since this is a straight line and it goes through 0, 0, it's proportional, and so this actually is our unit rate point. That tells us in 1 hour they went 3 kilometers, so that's 3 kilometers per hour. But again, we won't always have that luxury of having that set up, so just make sure we remember how to do this. it's the change in y over the change in x. So if we go from 0, 0 to 1, 3, that's going up 3 and over 1. So 3 over 1, which is the same as 3, is our slope. And then it asks what does it mean, and it means that Gina swims 3 kilometers per hour. Number 9, Donald graphs the distance he walks over time. The graph passes through the points 312 and 416. Part A, find the slope of the line that passes through these points. They could have just left it at that. They actually have a graph for us here. Again, not a fan of their triangles underneath here, but really, like I said, they could have just had the points 312 and 416, and they didn't even have to graph this for us. They could have just said what's the slope, and then we'd have to sketch it out or something. So change in y, our y values, we went from 12 to 16, so change in y is 4. I know it looks like 2, but that's because they're going by 2's. And change in x, going from 3 to 4, is a difference of 1. Again, looks like 2, but they're going by halves, so that's why it's different. So watch what your numbers are, not your blocks always, when you do these. So that's 4 over 1, which is the same as 4. And that technically means 4 miles per hour. So part A, slope would be 4. And then part B is the slope between 1 and 4 and 312, the same as the slope between 312 and 416. So if we look at that, 1, 4 to 312, (1, 4 to 312), we'd go from 4 to 12. 12 minus 4 is 8, so it's going up 8. We go from 1 to 3, so that's going over 2, so up 8 over 2. 8 divided by 2 also is 4. So the answer is yes. And we could say something like both slopes are equal to 4 or 4 over 1. So this gives you an idea of how to work with rate of change and slope.